Assalamualaikum and welcome to Cambridge Chemistry channel with sarwatahmed. Be sure to like the video and subscribe it. Really helps the channel to grow. In this video I will discuss chemistry paper 3 9700133 Feb March 2023. Let's start. In this video in this paper first question is about the thermal decomposition of basic metal carbonates. Why this is known as basic metal carbonates? Because in this compound metal hydroxide is also in the compound. This is the compound in which metal hydroxide is there. So these compounds are the compounds which have metal hydroxide, so that compounds are known as basic carbonates. So this is very important question because in context of thermal decomposition, and this is X water of crystallization. This is known as water of crystallization. And where X is an integer. In this experiment you will carry out a thermal decomposition of the composition to find the relative formula mass Mr and the value of X for a sample of basic zinc carbonate. Fa1 is basic zinc carbonate. This is the basic zinc carbonate which have zinc hydroxide along with zinc carbonate and X water molecules, and we have to determine X water, number of molecules of water, and as well as Mr of this compound. So that method. Let's start method. Weigh the empty crucible with its lid. That this is the shape of lid, crucible, and this is lid. So first weigh this empty lid, then transfer all the Fa1 from the container into the crucible, and weigh the crucible lid and Fa1. Weigh the crucible lid and Fa1 and record the mass. Place the crucible and content on a pipe clay triangle. This is the pipe tray and this is wire gauze, and heat the crucible gently with the lid on for approximately 1 minute, and heat strongly with the lid off for a further 4 minutes. Replace the lid and leave the crucible to cool for at least 5 minutes. And when you heat the lid, when you heat the compounds, remove this lid. So replace the lid and leave the crucible to cool for at least 5 minutes, and heat the crucible lid gently with lid on for approximately 1 minute and with lid off for 4 minutes. Now, while the crucible is cooling, you may wish to begin work on question 2 to 3. So this is about the cooling is for 5 minutes. You can continue other question or other part of question, so that's why to save this time. So while crucible is cooling, you may wish to begin work on a question 2 or 3. When the crucible is cool, weigh the crucible again with its lid and contents. Record the mass. Place the crucible and contents on the pipe clay triangle. Remove the lid. Heat the crucible strongly for further 2 minutes. Replace the lid and leave the crucible to cool for at least 5 minutes. Again use 5 minutes, so that you have enough time to begin work on the question 2 or 3. Calculate and record the mass of Fa1 used. Calculate and record the mass of residue obtained. So results carrying 5 marks if you draw proper table first mass of crucible plus lid gram, then mass of crucible plus lid plus FB1, sorry, FA1. This is FA1. FA1 before heating. Gram. Then mass of crucible, lid plus residue after heating. Don't write FA1 over here because this is now residue. Mass of crucible plus lid plus residue after heating. So write down the unit everywhere because otherwise you can't get marks of this table after reheating. Then mass of FA1 used to draw this table with the scale. Then mass of residue, gram. This is, let's suppose the mass of crucible plus lid is equal to 25.35 and this is, let's suppose, 27.25 and now this is equal to 26.72 and this is 26.70 and FA1 is like, for example, this is mass 1, this is M1, this is M2, this is M3, this is M4. Now mass of FA1 is equal to m2 minus m1, like 27.25 minus 25.35. This is equal to 27.35 minus 27.25 is equal to this is equal to 1.9, and mass of residue is equal to m4 minus m1. This is equal to m4, this is m4 26.70 minus 25.35 is equal to 1.35. This is 1.35. So if you draw a table like this and the difference between these two values is not more than 0.2, then you can get 5 marks of this table. Okay, with unit and with this correct headings, correct results, recording of results with units and with this pattern, and the difference between these two values should be not more than 0.2, then you can get 5 marks for this table. Now next question, calculation. The equation for the thermal decomposition is shown. Calculate the amount in moles of zinc oxide. We know mole of zinc oxide is equal to mass over mr. So mass, we have zinc residue, this is mass of residue, we have 1.35 divided by mr of zinc oxide is 81.4. This is equal to 1.35 divided by 81.4 is equal to 0.0. This is 0.0165 into, you can 0.6658. So this is the mole. 3 or 4 significant figures are required for mole. Hence calculate the amount in mole of basic zinc carbonate in your sample of Fa1. So this is the mole. By using mole ratio, we know that zinc carbonate dot zinc hydroxide dot XH2O ratio zinc oxide. We have 1:3 and mole is 0.01658 ratio X. The moles of this is 0.01658 divided by 3 is equal to 5.526 into 10 raised by 2 minus 3. So using your answer to be 1 and your result to A, calculate the relative formula mass mr of basic zinc carbonate. So mr, we know that mr is equal to mass over mole. We know the mass is 1.9 gram, and this is 5.526 into 10 raised per 2 minus 3. 5.526 into 10 raised per 2 minus 3 is equal to divided by 1.9 divided by 5.526 5.526 into minus 3 is equal to 343. 343.8. So use the periodic table to calculate the relative formula mass of Mr of this compound. Mr is equal to 65.4 plus 12 plus 3 into 16 plus 2 65.4 plus 2 into 16 plus 2 into 1. So when we calculate this, the value is 324.2. Use your answer to B2 and B3 to determine the value of X. We have all this compound ZnCO3 dot 2 ZnOH twice XH2O. This is equal to 324.2 plus X is equal to 18 H2O is equal to 343.8. This is 343.8 minus 343.8 minus 324.2. So this is equal to 343.8 minus 324.2 is equal to 19.6. 920. So this value should be, we can change this value because the value should be, X value should be equal to whole number. If we place 1.48 over here, 1.48 over here, then the answer is 1.48 divided by 81.4 is equal to 0. This could be equal to 0.0181. So we can change this value in previous table as well. Let's calculate first. 0.0181, because this value should be more, this value should be more than 324. uh, 0.0181 divided by 3 is equal to 6.03. This is equal to 0.01. This is equal to 6.03 into 0.3 into 10 raised power 2. Can I calculate correct? 1.48 divided by 81.4 is equal to, this could be 2, and this is now 0.0182 divided by 3. This is equal to 6.06 into 10 raised power 2. 6.06 into 10 raised power 2 minus 3. 6.06 into 10 raised power 2 minus 3. 1.9 divided by 6.06 into 10 raised power 2 minus 3 is equal to 1.9 divided by 6.06 into 6.06 into minus 3 equal to 'So if we the same amount we have taken, and if the value of mass is 2 gram, residue is 2 gram, we get 361.8. So this is the reasonable MR of zinc carbonate, because we have to subtract from this to get mole of water. So this is now 361. So I made residue mass is 2 gram, Fa1 is 2 gram. 361.8. now 360. So this is supposed reading 361.8, and now you can use your own reading. Okay, 1.8 in exam, you can use your own reading. 361.8. the answer is 361.8 minus 324.2. So this is equal to 37.6 is equal to 18H2O. Now H2O is equal to 37.6 divided by 18. Divided by 18, we get the mole of water. So this is whole number 2.0. So this is how to calculate the MR of compound and mole of water. This is X is the mole of water. So now we can change over here. So this should be 1, 2. This should be 2. So if we make 25.36, 27.25 minus 25.36, .35 plus 2 equal to 27. This should be 35. So in this way we have this value, and M4 minus M1, M4 is this 26.70 minus 25.35. So we get the 3.1. Now this is the, and the difference between these two values should be not more than 0.2. Please be attentive, be careful while taking this reading, these two readings. So this is how to calculate this question. So this is very different question of thermal decomposition. So it is also very important because this is March paper of March 23, question paper 23. So next 24, the similar or same type of question is expecting, okay, in 3-4 exam. So next question is of this paper. In this experiment you will determine the relative formula mass MR of basic, same question basic, but in this question basic zinc carbonate is using of MR by alternative method by reacting this compound with HCl. A known mass of basic zinc carbonate is reacted with a known volume of concentration of hydrochloric acid. The acid added is in excess. You will titrate portions of the resulting solution with sodium hydroxide of known concentration. Fa2 has been prepared as follows. 3.52 gram of basic zinc carbonate is reacted with 100 centimeter cube of 2 mole per dm cube of hydrochloric acid. The resulting solution is diluted to 1 dm cube with distilled water. Fa3 is 0.150 mole per dm cube of sodium hydroxide. Fa4 is bromophenol blue indicator. Now fill the burette with Fa3. Fa3 is the sodium hydroxide. Now pipette 25 centimeter cube of Fa2 in a conical flask, which is this basic carbonate, basic zinc carbonate. And I have earlier discussed that basic carbonate is the compound which have metal hydroxide along with the carbonate. So pipette 25 centimeter cube of Fa2 in conical flask, add several drops of Fa4 to the conical flask. Perform rough titration and record your burette reading. You know this reading, this table I have discussed earlier so many times that this table is very important. So make exact correct table to carry to get these 7 marks. So first, for rough titration, final burette reading of Fa3 and write down unit over here, centimeter cube. Initial burette reading Fa3 centimeter cube. So this is 0.00. Volume of Fa3 used is 26.0. So the rough titer is 26.00. Carry out as many titration as you think necessary to obtain consistent results. Make sure any recorded results show the precision of practical work. Record in suitable form below all your burette readings and the volume of Fa3 added in each accurate titration. So this is the accurate titration. Please don't use rough titration in this table. So this is we started from initial reading is 2.00 and final reading is 23.0 and we get 21.00, and the next initial we start from 23 and the final reading is 44 and volume of Fa3 used is 21.00. So don't no need to carry out third experiment because you have two consistent reading. So this is best titration. From your accurate titration result, calculate a suitable mean value to use your calculations. 21 plus 21 divided by 2, that is equal to 21. This is equal to 21.00. Now calculate the amount in mole of sodium hydroxide present. This is very important point. Give your answers to C2, C3 and C4 and C6 to an appropriate number of significant figures. Calculate the amount in moles of sodium hydroxide present in the volume of Fa3 in B. So this is equal, you know that mole is equal to concentration into volume in centimeter cube divided by 1000. So this is the concentration 0.150 into 21 is the volume in centimeter cube divided by 1000. So amount of mole is 3.15 into 10 raised to minus 3. Use your answer to C2 to calculate the amount in moles of hydrochloric acid present in 1 dm cube of Fa2. So by using mole ratio, we know that there is 1:1 ratio between sodium hydroxide and HCl. So the moles of sodium HCl is 3.15 into 10 raised to minus 3. Use your answer to C2 to calculate the amount in mole of hydrochloric acid present in the 1 dm cube set. We know that these moles are in 25 centimeter cube, and what would be the mole in 1000 centimeter cube? That is equal to X. So by cross multiplying, we get the mole of HCl in 1 dm cube of Fa2, which is equal to 0.126 mole. Use your answer to C3 and the information about the preparation of Fa2 to calculate the amount in mole of hydrochloric acid that reacted with 3.52 gram of basic zinc carbonate. So first calculate the total moles of HCl, which is again equal to concentration into volume over 1000. So we have 2 moles of HCl. Concentration of HCl is 2 mole into now this is the concentration of HCl is 2 and volume which is used is 100 centimeter cube. Look, this is the 100 centimeter cube of when we prepare this solution. Yes, 2 mole per dm cube, 100 centimeter cube of 2 mole per dm cube hydrochloric acid. The resulting solution is diluted. This solution is diluted to 1 dm cube. So that's why first of all calculate the total mole of HCl which is concentration into volume over 1000. So this is equal to 0.2. So total HCl mole is 0.2 is equal to reacted HCl plus remaining HCl. So reacted HCl we have to calculate X, and the remaining mole is 0.126, which I have calculated above. So X is equal to total mole is equal to 0.2 minus 0.126, which is equal to 0.074 mole. Using part 5, using the equation given in question 1b as a guide, complete the equation for the reaction of hydrochloric acid with basic zinc carbonate. State symbols are not required. So zinc carbonate, this is the basic carbonate of zinc plus HCl to form ZnCl2 plus water plus carbon dioxide. So there are 3 atoms of zinc on the reactant side, so place 3 over here, and water over here is X, and 2 to the 4, 2 hydrogen atom over here, and X is here. So five plus X is the this, and 1 from here, so 5 plus X H2O plus CO2. Use your answer to C4 and the equation in C5 to calculate the amount in mole of basic zinc carbonate in 3.52. So by using mole ratio, basic carbonate has 1 mole reacting with 6 moles of HCl, and 0.074 moles I have calculated above is equal to 0.0123. by now hence calculate the relative formula mass Mr of the basic zinc carbon. We know that Mr is equal to mass over mole, so mass is 3.52 and mole is 0.0123. the answer is 286.2. so this is the Mr of this basic carbonate along with water molecule. A student, question number D, a student correctly followed all the instructions in A to C of this question. The formula mass the student calculated was smaller than the correct value. The student suggests that this may be because the concentration of sodium hydroxide Fa3 is greater than 0.150 mole per dm cube. We know that if we use more concentration, smaller value of titer is used. So we have sodium hydroxide is used as titer. So if more concentration, then smaller value of titer is used. So explain why the student is correct. Because more concentrated sodium hydroxide gives smaller value of titer, so calculated remaining mole of HCl would be smaller or less. So reacted HCl mole would be greater, and moles of basic carbonate would be more having same mass, so give high value of Mr. So this is all about of the question number 1 and question number 2. Hopefully you understood this question. If you understood, please like the